This lesson is for Mrs. Cucci's College Now Pre-Calculus class. Today we're going to be talking about solving equations in 3 variables. This will be broken up into 2 videos. The first video will focus on solving the systems, whereas the second video will focus on applications. So in order to begin, we probably should talk about what a system in 3 variables is. Well, it's actually exactly what it sounds like. It's 3 equations using 3 variables, for example, x, y, and z. Instead of, like we're used to, having an ordered pair as a solution because we had 2 equations and 2 variables, because we had 3 equations, we're actually going to have what's called an ordered triple. An ordered triple is what it sounds like. It's 3 terms, or 3 expressions or solutions, because we have 3 different variables. So 2, -1, and 0 would go along with our x, y, and z. Okay? In order to verify that these solutions are appropriate for our system, you would have to substitute them back in. You would have to make sure that you're substituting them back into all 3 equations, not just one of them. All right, so we're actually going to use a method that we already know how to use, and that's the Gaussian elimination method. We do have 3 steps to follow. However, I think it's probably going to be easier for you to see how to do a problem and then determine what the steps are on your own after that. Okay, so elimination method is something that you've seen before. We've done this in 9th grade and we did it again in 11th grade, so this should be review. The new aspect to it is now instead of just solving for x and y, we're now using 3 variables, x, y, and z, so it does put a little bit more work into the problem. So let's look at our first system. So here's my system, x minus 2y plus 3z equals 11. That's equation number 1. Equation number 2, 4x plus 2y minus 3z equals 4. And equation number 3 is 3x plus 3y minus z equals 4. So basically what's going to happen here is we're going to use equation number 1 in order to eliminate x in equation 2. And then we're going to use equation number 1 to eliminate x again in equation 3. And all of this is going to be done through elimination. So essentially, we're looking for our x's to cancel out. So with elimination, we know that sometimes we have to multiply one equation through by a constant. Sometimes we have to multiply both equations through by a constant. Sometimes we don't have to multiply through by anything at all. It already cancels for us. So if I'm focusing on equation 1 and equation 2, and I want the x's to cancel, I am going to have to go ahead and multiply my first equation through by something in order to get that 4x to cancel. And you guys know that in order to get that 4x to cancel, we're going to have to multiply that first equation through by a -4. Okay? So when I do that, I get -4x plus 8y minus 12z equals -44. Okay? So now what I'm going to do is I'm going to bring over that second equation, 4x plus 2y minus 3z equals 4. And I'm going to go ahead and do my elimination process. X's cancel. I get 10y minus 15z equals -40. And we're going to call this equation 4 because it is going to be used again. Okay, so we did that for the first equation to get the second equation's x's to cancel, right? So we're going to do the same thing again, except we want to work with 1 and 3 now. So what will I have to multiply 1 by to get the x's to cancel in 3? And we know that's going to be a -3. So let's distribute that through. Okay, I apologize, this is a new stylus and I'm not used to it yet, so it's going to be a little sloppy until I get used to it. Okay, so there's my first equation. Bring down that third equation. And we add. And we'll call this equation 5. Okay. So basically what we've done is we've created 2 new equations. So it's like a system of equations in 2 variables. Now we know how to do that. We're going to go ahead and we're going to use elimination again. Okay? So those are my 2 variables. we're going to use elimination, except in this case, in order to get either the y's or the z's to cancel, we're going to have to multiply, it looks like, both of them through by something. So let's focus on eliminating the y. If I want to eliminate the y, let's say we would have to multiply this through a -9, and then this through by a 10. Right? That would allow for that to eliminate. So that's going to give me -90y plus 135z equals 360. That's my first one, right? My second one here, 90y minus 100z equals -290. Add those together, the y's are going to cancel. We're going to get 35z equals 70, or z equals 2. So what I've actually done now is, if we're talking about our ordered triple, right, what I've found is I have found my z. What I have to do is find my x and my y. Now, we had two equations, right, that we made for ourselves, here and here. Those are just in terms of y and z. If I know z, that can very easily find me my y by using substitution, right? So I can do that. 10y minus 15 times 2 equals -40. 10y minus 30 equals -40. 10y equals -10. Y equals -1. So now we have x, we have -1, and we have 2. So now what I'm left with finding is y. Well, now we have, we need x. We have y and we have z. We can use any of those three original equations to find us our x. So I'm going to go back and I'm going to use that very first equation in order to find it. That first equation was x minus 2y plus 3z equals 11. And the reason I use that one is because everything else, the other two had coefficients in front of the x. This one doesn't. Just makes it a little bit easier. So x minus 2 times -1 plus 3 times 2 equals 11. X plus 2 plus 6 equals 11. X equals 3. So my solution, my ordered triple, is 3, -1, and 2. So that is your first glimpse at how we solve a system in 3 variables. Okay. So let's look at another example. This one's going to be a little bit more difficult. Same kind of process. You're going to use that first equation to eliminate the x in the second. You're going to use that first equation again to eliminate the x in the third. You're going to use your 2 new equations that were created through that process to try and eliminate the y. Okay, so same idea. That'll give us the z. You plug back in to find the y. You plug back in to find the x. So you kind of work backwards after that. So let's do that. We're going to work with 1 and 2 to start. So what would I have to multiply the first equation by to get the x's to cancel in the second? Looks like that's going to be a -3. And we're going to distribute. Okay, we're going to bring over that second one. And we're going to add. And this creates equation 4. We're going to do the same thing again, but now we're working with 1 and 3. So it looks like we have to multiply through by -1. So -x minus y minus z equals -7. X plus 6y plus 3z equals 25. And we add. Yikes. My adding is horrific today. Pardon me. There we go. Okay, and that's equation 5. All right, so we're down to 2 equations, 2 variables, right? 4 and 5. So now the goal is to get the y's to cancel. What do I need to multiply by? Well, if we look at this, it looks like those y's would already cancel. So we're going to rewrite that system so that they're over each other. And we're going to add. And what winds up happening is we get 0 over 0. And that means something special. What that means is this solution, this system, has infinitely many solutions. Okay? Infinitely many. So we can't just have 1, 2, and 3 as solutions. We actually have to have expressions that will allow us to find every single solution available to us. Okay? So it's actually going to be in terms of the variables. Your solutions are going to be in terms of the variables. So what we're going to do is, because we have, let's say, this equation here, okay, we can use this equation to get expressions for our solutions. So we're going to keep our solutions in terms of z. Okay? So we get an expression for x and an expression for y. So we can really easily use this equation to find what y would be just by isolating the y. Okay? So now that's this right here. Remember, we want everything in terms of z. All right? But now we need x in terms of z as well. But what we did is we just found us our y, right? I can go back and use my original equation, that first equation, to find it in terms of z. All right? So that original equation was x plus y plus z equals 7. Well, now I know what y is. X plus negative 2/5 z plus 18/5 equals 7. Isolate that x. 7 minus 8 minus, 7 minus 18/5 plus 2/5 z minus z. So we get x equals negative 3/5 z plus 17/5. Okay, so that's my x. Negative 3/5 z plus 17/5. That's a little hard to read, so let me write it bigger for you. Negative 3/5 z plus 17/5. Negative 2/5 z plus 18/5 and z. Infinitely many solutions, right, that can be found using these expressions. And I think maybe I need a new stylus. All right, so that is how we solve systems in 3 variables. Tomorrow we will work on the application problems. So please come prepared with any questions, and we will review when you come to class. We'll see you then.